This is a pretty big casting, though not as big as that one. So is this around 8,000 tons? No, actually, it's 6,500 tons for the front and 9,000 tons for the rear. Oh, okay. So just to clarify, tonnage is essentially about how much metal you're moving within the plate and size and how fast you're moving it. But you can restrict that metal flow by making bad feeds in bad directions. But when you look at the flow, the biscuit comes in through the middle, and then we flow it all out just like a river. Because, metal wants to move like a river. A lot of times when you see these people copying us, and maybe I'm giving it away, but it's an engineer's route, right? And they draw triangles and trusses, but here at Tesla, we have in-house die designers who sit right next to the guys designing the castings, and they're going back and forth in simulations so that we can lower the tonnage of the presses we're using by integrating the design of the part into the design of the tool, which is why we don't necessarily need a 10,000-ton press for the front. When we started, we thought we would. We said, oh, we're going to need 8,000 tons, but we worked through the team and we actually can make this front one on the same equipment as we make Model Y. That's amazing. But the rear one's too big? Yeah, well, it helps the cycle time too, right? Yeah, it does help the cycle time because you get more even cooling across the whole thing. Well, that's the big thing. Cooling and warpage. Everybody asks that question. I mean, how much does this warp? And I said, well, it happens so quickly, it shouldn't warp at all. But yeah, I mean, it's really about how long we cool it in the D. You let the skin cool, and then when you pull it out, we don't have straighteners or anything. So how many presses are pushing these out now? We have one for the front and two for the rear. But as I said, we have Model Y one, so we have 4 of those. Swap the TI, yeah, but we only need 2. Like cycle times are down enough to make, 5,000. We only need 2 presses, one for the front and one for the rear. Do you bother with backup tooling then? Yeah, we swap the tools out. 3 sets of D, so, well, at least 2. If we're running one, then we have 1 backup. Otherwise, we'll have 2 in and 1 backup, and we'll rework the one while we're running the other 2. And, when casting machines go down, they go down hard. Right? Yeah, so you've got to get the tool out and get a new one in quick, right? Yeah, exactly. Now, let's dive deep into the world of automotive innovation as we uncover a jaw-dropping revelation from Tesla's lead design team in a recent interview with Sandy Munro regarding the Cybertruck. So what's the buzz all about? It's all centered around Lars Moore's unexpected revelation, a revelation that might have slipped under the radar but holds the key to Tesla's manufacturing prowess. In a world where innovation reigns supreme, Tesla has once again proven its mettle. Stay tuned as we explore how Tesla's groundbreaking approach to casting, backup tooling, and production numbers is setting them apart in the race to produce hundreds of thousands of vehicles annually. But that's not all. We'll also discuss how this revelation could send shockwaves through the automotive industry, possibly leaving even the mighty Ford F-150 Lightning trembling in its tracks. Don't miss this electrifying episode, but first make sure to hit that like and subscribe button. Welcome to Tesla Stock News, and let's delve into the details of this groundbreaking revelation. In a recent interview conducted by Sandy Munro with the Tesla lead design team regarding the Cybertruck, a significant revelation was made by Lars Moravi that appears to have been somewhat overlooked. Let's delve into this noteworthy revelation. When Lars Moravi mentioned that they could produce the front Giga casting using the same size press as the one employed for Model Y Giga castings, it caught everyone's attention, as Munro also exclaimed. This revelation underscores the remarkable capabilities of Tesla, not only in terms of their design engineers, but also their assembly line workers. Their ability to swiftly iterate and adapt due to physical proximity sets them apart from the traditional approach in the automotive industry. It's one of the key reasons why Tesla remains a formidable force, outpacing legacy automakers. Most of you probably know that the Giga casting is a substantial casting, although not as large as some others, with a tonnage of 6,500 for the front and 9,000 for the rear. The fascinating aspect here is how Tesla manages the metal flow, akin to the movement of a river. Unlike other attempts where engineers simply draw designs with triangles and trusses, Tesla employs in-house die designers who work in close collaboration with casting designers. This collaboration results in simulations that optimize part designs to reduce the required press tonnage. Surprisingly, for the front casting, they can use the same equipment as for the Model Y, a testament to their innovation and efficiency. However, the rear casting remains too large for this shared approach. This innovation not only impacts tonnage but also cycle time, ensuring more uniform cooling throughout the casting, addressing concerns about warping. They've achieved rapid cooling without the need for straighteners. At present, they have one press for the front and two for the rear alongside Model Y presses. Nevertheless, due to reduced cycle times, only two presses are necessary to produce 5,000 units daily. This revelation underscores Tesla's groundbreaking approach to manufacturing and design, setting them apart from the conventional automotive industry. It's yet another testament to their ability to revolutionize the industry. Do they have backup tooling? Indeed they do. Sandy asked about it, and it turns out they maintain 3 sets of dies while at least 2 are in use at any given time. If they're running one, they keep another as a backup, and they're able to rework the idle die while the other 2 are in operation. This precaution is necessary because when casting machines break down, they do so abruptly and without warning. To keep the production line running smoothly, they must swiftly replace the tools. You might be wondering why they need these backup dies. Lars explained that it's crucial because when a casting machine goes down, it can have serious consequences for production. It's a race against time to remove the faulty tool and insert a new one promptly. Hence, they always have backup dies on hand, or as Lars put it, they recycle them continuously, rotating and maintaining the dies to ensure seamless production. Sandy initially asked whether the machine for the front Giga casting on the Cybertruck was an 800-ton machine. Lars swiftly corrected her, stating that it was a 60,000-ton machine, the same size as the one used for the Model Y. This revelation holds significance because it means the Cybertruck's production process takes up less space and operates more efficiently. It's like having a 2-bedroom house instead of a 3-bedroom one, a compact and efficient setup. Furthermore, Lars mentioned that they have multiple Model Y machines in the factory, allowing them to utilize those machines for Cybertruck's front Giga casting as well. This flexibility is crucial because, as Lars noted, these dies have a finite lifespan, and when they fail, they do so abruptly, causing disruptions in production. It's a pretty big deal. But what truly left viewers in awe was the sheer scale of the operation. When taking a tour of the factory, observers couldn't help but marvel at the Giga castings, particularly the front one. The simplicity and efficiency with which it was designed were truly remarkable. Even though they might not have the technical expertise of an engineer, anyone could see that something innovative was at play. What's truly remarkable about this whole process is how they've managed to enhance the flow of metal through the Giga press. Imagine this metal being injected from the middle, flowing horizontally, and then swiftly filling up the sides of the casting cavity, all within fractions of a second. The key is to keep the metal from cooling down too much and causing blockages. It's almost like guiding a river, allowing the liquid metal to flow freely. This design is the result of collaboration between design engineers and the assembly line team, a partnership that has fine-tuned the process to perfection. If we take a closer look at the exterior, you'll notice these elegant wavy lines running through the casting. These lines aren't just for show, they provide essential structural support. Without them, the casting wouldn't have the rigidity required to bear the weight and torque demands placed upon it. Traditionally, the approach would involve constructing the design with a complex network of triangles and meshes, much like creating a 3D animated character. However, all those triangles and meshes acted as barriers, impeding the flow of the metal. What Tesla has achieved is a remarkably smooth design with raised ridges that offer an unobstructed path for the liquid metal to flow through. This innovative method ensures rapid, homogeneous flow, preventing irregularities or blobs in the casting. As the metal cools, its crystalline structure becomes exceptionally rigid and robust. Tesla's material science team, often sharing their expertise with SpaceX, has played a pivotal role in developing a specialized aluminum alloy with the ideal property smooth flow when hot, rapid cooling, and a strong crystalline structure when solid. The result? A casting process that is as efficient as it is effective. Now, what sets Tesla apart is their ability to seamlessly integrate the design of the casting into the machine's design that manufactures it. This level of synergy is the linchpin of their success. While anyone can create a prototype, Tesla's real challenge lies in mass production. They've mastered the art of efficiency and quality, ensuring that each component fits perfectly without the need for costly adjustments down the line. It's this commitment to excellence that sets Tesla apart in the race to produce hundreds of thousands of vehicles annually. When traditional manufacturing methods involve numerous stamped parts that need to be welded together, a cascade of challenges emerges. Not only does it entail managing a multitude of parts and deploying a plethora of robots, but it also presents alignment issues as these disparate parts come together at the final assembly stage. Adjustments become necessary, sometimes requiring forceful interventions like wielding sledgehammers. All of these hurdles translate into increased cost and reduced efficiency, with more manpower required to ensure everything fits seamlessly. The result is a vehicle that may not achieve the level of perfection attainable through die casting. This approach exemplifies the first principle mindset, wherein the goal is not just to build a car, but to do so with utmost efficiency. Furthermore, in the interview, there's substantial discussion on safety, a topic of concern for many regarding the Cybertruck. These giga castings play a pivotal role in addressing safety concerns. They incorporate specific crush zones strategically located at the front and rear of the vehicle. As impact occurs, these zones absorb the force, allowing the structure to collapse predictably and protect the occupants. During one-on-one conversations with an engineer at the factory, it became evident that the motor and batteries have been ingeniously designed to slide out of harm's way in the event of a collision. The motor drops below the batteries, reducing the risk of injury. Additionally, the transition to steer-by-wire eliminates the traditional steering column, eliminating a significant safety hazard, the possibility of it penetrating the cabin in a collision. This, combined with the inherent safety features of the giga casting, makes the Cybertruck a strong contender for achieving top safety ratings. Now let's delve into the production numbers mentioned by Lars. He hinted at a target of 5,000 units per week for the Cybertruck. This means Tesla is aiming to roll out 5,000 Cybertrucks weekly, encompassing both the rear and front giga castings, taking into account some downtime over the year, and assuming 50 weeks of active production. This equates to an impressive 50,000 Cybertrucks annually. However, it's worth considering that Tesla might be underestimating its capabilities. With the potential to have 2 production lines and an additional 4 Model Y presses for the front giga casting, they could easily surpass this target. The real limiting factor currently seems to be the availability of the 90,000-ton giga press for the rear casting. If both presses operate simultaneously, production rates could potentially reach 7,500 units per week, exceeding the initial projection. Sometimes they're hitting the mark at 10,000 units per week, but occasionally they have to take one out of service for maintenance. So let's consider an average of 7,500 units per week. This pushes their yearly production up into the range of 300,000 to 350,000 Cybertrucks annually, as opposed to the initially projected 250,000. Now, there's a suspicion brewing that they might already have a second Cybertruck production line up and running, in addition to the one we've seen. This suggests that Tesla could potentially be churning out well over 250,000 of these vehicles each year once they hit full-scale production. What's even more intriguing is the alignment with Joe's flyovers and recent Cybertruck deliveries. Yes, folks, people are actually receiving their Cybertrucks right now. This isn't a case of Tesla making 10 trucks and saying, hey, production starts in 2024, they've kicked off deliveries for real, and some lucky individuals like Mars catalog, who've placed their orders and put down the money, might get their hands on the trucks even before 2024. This all points to Tesla being in an enviable position when it comes to Cybertruck production. Now, let's talk about the competition. The Ford F-150 Lightning should be feeling a little jittery right about now. Ford recently revised their estimated production numbers from 160,000 to 880,000 units for 2024. But here's the kicker: Tesla could easily hit 75,000 too. 80,000 Cybertrucks next year alone. That's right, Tesla might just produce more Cybertrucks in 2023 than Ford with its F-150 Lightning in 2024. This should send shivers down Ford's spine because their F-Series trucks are the lifeblood of the company, the best-selling vehicles in the United States for decades. So the potential disruption in this arena is substantial. So I guess that's it for this video. What do you think of all these recent developments? Let us know your thoughts in the comment section below. And if you enjoyed this video, don't forget to hit the like and subscribe buttons. Thank you for watching, and see you again in our next videos.